Hi, I put together a little review for hypothesis testing. So I'm going to share the document. This document should also be available on Blackboard. So sharing my screen, the first question that I want to look at, actually these questions come from your text, is problem 9.87. According to the Bureau of Crime Statistics and Research in Australia, as reported on LawLink, the mean length of imprisonment for motor vehicle theft offenders in Australia is 16.7 months. 100 randomly selected motor vehicle theft offenders in Sydney, Australia had a mean length of imprisonment of 17.8 months. At the 5% significance level, do the data provide sufficient evidence to conclude that the mean length of imprisonment for motor vehicle theft offenders in Sydney differs from the national mean in Australia? Assume the population standard deviation of the length of imprisonment for motor vehicle theft offenders in Sydney is 6 months. And you're asked to use the critical value approach. All right, so I'm going to move over to the whiteboard here. And I'm going to reread the problem and pull out the important values. Okay, so the mean length of imprisonment in Australia is 16.7 months. So that would tell us, you know, given the context of the whole problem, that the null mean that we're testing against is 16.7 months. We have 100 randomly selected offenders in Australia having a mean imprisonment. So we have 100, that's my sample size. And they have a mean imprisonment of 17.8. So the sample mean of a sample of size 100 is 17.8. We're asked at the 5% significance level, so alpha is 0.05, do the data provide sufficient evidence to conclude that the mean length of imprisonment for motor vehicle theft offenders in Sydney differs from the national mean in Australia? So I'm going to go ahead and grab that differs word. That's going to be the key word for my alternative hypothesis. Okay, so we have mu, the null mean. The null hypothesis is that the mean is 16.7, and the alternative hypothesis is that the mean is not 16.7. Just going to tuck that up there as the first step in the hypothesis test. Okay, and we're also told to assume that the population standard deviation of lengths of imprisonment for motor vehicle theft offenders is 6 months. So, as with all of these inferential problems in our course, when we see the word standard deviation, we need to go back and determine if that standard deviation is an S or a sigma. Does it come from a sample, or is it a measure of the population? And in this case, the key word, the important word is right there in the sentence. Assume that the population standard deviation is 6 months. So we have the population standard deviation is 6. Okay, so we're going to use the 6 steps of hypothesis testing. The first step is the statement of the null and the alternative. And the second step is a statement of the significance level. And that was given in the problem right there. The third step is a calculation of the test statistic. So before I can write down the test statistic, we need to figure out if I'm going to be doing a z-test or a t-test. So going over to the formula card, just to check on this, and I'll pull that and well, going straight to the chapter 9 formulas, we see that the formula on the left is the Z statistic when sigma is known, and the formula on the right is the T statistic when sigma is not known. So we're working with a sigma, population standard deviation is known, and whenever we know sigma, we do Z. So we're going to use the formula for the Z statistic here. So Z is equal to X bar minus mu naught divided by sigma over the square root of N. Substituting in from the values that we have listed on the side here, X bar is 17.8, mu naught is 16.7, and the denominator is 6 divided by the square root of 100. Okay, the calculations, the way I manage the calculations in these problems is to always calculate the numerator and then calculate the denominator and then divide. So I never really want to work with all of those numbers at once. I know some people are really comfortable with that, but I always have better accuracy when I separate my calculations. So the numerator is 1.1, and the denominator, 6 divided by the square root of 100, is 6 divided by 10, or 0.6. And this is a z-score, so we're going to express this to 2 decimal places. Uh, 1.83. Okay, so that is the value of the test statistic. In step 4, we are asked, in this problem, we were asked to use the critical value approach. So then in step 4, for the critical value approach, is the determination of the rejection and non-rejection regions. Okay, so to do that, we're going to look at some of the steps up here. So the first step will tell me the shape of the rejection region, and the set, and what we see for the not equal to, that tells us that we should be using a two-tailed test. Okay, and the second step tells me the size of the rejection region. So the two tails together have to equal 0.05, which means that each tail has to be 0.05 divided by 2. And we get 0.05 divided by 2 is 0.025. Let's clean that up a little bit. And that's in each tail. Okay, so the center region is my do not reject, the null hypothesis, and the two tails make up the rejection region. So go to the formula card and let's find out what the delimiting values are for the rejection, that delimit, the values that delimit the rejection, non-rejection region. We also call those the critical values. So we can go to the last page in the formula card. And refer to the small box down here. All right, so we're looking for Z sub 0.025, and we get that to be 1.96. And by the symmetry of the distribution and the problem that we're working, this side here is the critical value over there is negative 1.96. All right, and so that's step 4. We're going to get step 5. Well, step 5 is where we make our decision. Okay, so in the critical value approach, step 5 requires that we take the test statistic from here, from step 3, and we plot it on the graph in step 4. So we're going to use step 3 and step 4 to make our decision to complete step 5. So we're going to take 1.83 and graph it. Now, in order to figure out what region this falls in, remember that the center of the distribution is at 0, and this is really just a number line. So where on that number line does 1.83 fall? Well, it falls between 0 and 1.96. I'm going to put a big red circle here, and that's my Z statistic, my test statistic, 1.83. So now we have to make our decision. We look at where that test, what region that test statistic fell in, and it fell in the do not reject region. So the conclusion is, the decision is to do not reject the null hypothesis. Okay. And finally, let me see if I can get a little space over here to state the conclusion. All right, so the conclusion starts with at the 5% significance level. The data does not because we did not. Data does not provide evidence that we want to make a statement about the alternative hypothesis, that the mean time or the population mean time is different than 16.7. All right. Okay. So this is an example of a two-tailed critical hypothesis test, a two-tailed Z-test. Okay. So we're going to go on to the next problem. I chose 3 problems, and these 3 problems really encompass what we're covering in chapter 9. Okay, so I'm going to go and share my screen. And we're going to go to the next problem. And so let's see. So this is problem 9.88 from the text. And notice that here I'm asking that you use the p-value approach. So a study by M. Chen titled Heat Stress Evaluation and Worker Fatigue in a Steel Plant assessed fatigue in steel plant workers due to heat stress. A random sample of 29 casting workers had a mean post-work heart rate of 78.3 beats per minute. And the question asks, at the 5% significance level, did the data provide sufficient evidence to conclude that the mean post-work heart rate for casting work exceeds the normal resting heart rate of 72 beats per minute? Assume that the population standard deviation of post-work heart rates for casting workers is 11.2 beats per minute. All right, and you're asked here to use the p-value approach. Okay, so while I turn the board around, if you can start to pull out the important information from the problem, you're going to look for a mu naught, sample size, and x bar, alpha, and whether or not your standard deviation is sigma or s. So maybe even stop the video here, give it a shot to try and pull the important parts out, and get as far as you'd like, and then come back, turn it back on, and I'll present the solution on the whiteboard. Okay, so I'm erasing while you guys give the problem a shot. Okay, so jumping in and looking back at the statement of the problem. Okay, so we have a random sample of 29 workers, and those 29 workers had a sample mean of 78.3 beats per minute. We are asked at the 5% significance level to carry out a test. So alpha is 0.05. And do the data provide sufficient evidence to conclude that the mean post-work heart rate for these workers exceeds the resting heart rate of 72 beats per minute? So there's a lot of information in the sentence in your problem that has the question mark. So looking back, you can read that again. I'm getting two things. I'm getting the keyword for the alternative hypothesis, right? So see if you can find that. Exceeds, right? So we're gonna exceeds. And what does it have to exceed? The null mean, which is 72. So the null and alternative hypothesis are stated, sorry about that. There you go. All right, so that's the null and alternative hypotheses. Okay, so the second step in the problem, still need one more piece of information. Assume that the population standard deviation of post-workers' heart rates is 11.2 beats per minute. So is that standard deviation a sample standard deviation, which would be indicated with an S, or is it a population standard deviation, which would be denoted with a sigma? And it says explicitly in the problem statement that that's a population standard deviation. So that's sigma, and sigma is equal to 11.2. Okay. All right, so I think now we have all the information on the board to do the problem. The second step in the hypothesis testing procedure is the statement of your significance level. And this problem is requested to be done at alpha equals 0.05. That will always be given to you. And now the third step is to calculate your test statistic. So back to the formula cards to determine whether we're going to be doing a T statistic or a Z statistic. Looking down at the chapter 9 formulas, it's again, sigma is known, so we're going to use the Z. So the formula we're interested in is X bar minus mu naught divided by sigma over the square root of n. So subbing in all the information here, 78.3 for X bar, mu naught. I didn't put it there, but let's get into that. Is 72, and sigma is 11.2, and the sample size is 29. Okay, so we're going to calculate numerator and denominator separately. So that's 6.3 in the numerator and the denominator, I get 11.2. I'm sorry, I get 2.08. And the ratio to 2 decimal places. Again, 2 decimal places because this is a z-score and we're going to refer back to z-tables. Okay, so the value of the test statistic is 3.03. Now, because we're doing the critical value approach, step 4 and step 5 are different than in the previous example when we were doing, we're doing the p-value approach, and that differs then from the critical value approach, which we had done in the first part of the video. Okay, so in step 4 for the p-value approach is the calculation of the p-value. So to calculate the p-value, we're going to use the fact that we have a greater than, that we're doing a right tail test, so that the p-value is going to be the area defined by the test statistic. And in this case, we're only going to use one of the tails. We're going to use the right tail. So coming in here, and it's the right tail defined by the test statistic. So what we're looking for is, if we put our test statistic in here, my p-value is that area of the tail defined by the test statistic in the direction of the alternative hypothesis. So what we're looking for is the area to the right of 3.03. So the area to the right of 3.03, because we're given the z-score and looking for an area, we're going to use a direct lookup. So going over to the table, and this time we're using this table and looking up 3.03. The table gives us a left tail. So the strategy to get the area of a right tail is 1 minus your direct lookup. So I have 1 minus 0.9988. That is my, after I subtract, is going to be my p-value. And I get 0.0012. That's my p-value. And that's the completion of step 4. So step 5 is where we make our decision. And in the p-value approach, we have to compare alpha and p-val. All right. And so alpha is 0.05. And p-value is 0.0012. Which one is smaller? The p-value is smaller. When the p-value is less than alpha, when the p-value is small, that leads us to the decision of reject the null hypothesis. That's the criteria in the p-value approach. And then step 6 is a statement, is your interpretation. The lattice space on the board, so I'll just tell you, do it verbally. So at the 5% significance level, the data does provide, because we did reject. So at the 5% significance level, the data does provide evidence to conclude that the heart rate, the post-work heart rate, is greater than 72. All right, so that's our second problem, our second hypothesis testing problem. I have one more that I wanted to include in this review, and I think those three problems together really encompass the sorts of problems that we are trying to get understood in chapter 9. All right. So the third problem is about dirt bikes. So dirt bikes are simpler and lighter motorcycles that are designed for off-road events. Specifications for dirt bikes can be found through Motorcycle USA. On their website, can be found on the Motorcycle USA website. A random sample of 30 dirt bikes have a mean fuel capacity of 1.91 gallons with a standard deviation of 0.74 gallons. At the 10% significance level, do the data provide sufficient evidence to conclude that the mean fuel tank capacity of all dirt bikes is less than 2 gallons? And we're asked here to use the critical value approach. Okay, so I'm going to switch back to the whiteboard, try to read the problem, and pull out the important information as I do that. Okay, keeping a little bit of the problem structure on the board. So it begins to feel as if it's a template. And we build a little, memory about how to set up the problems. Okay, so in this problem, we have a random sample of 30 dirt bikes. So my N is 30. They have a mean fuel capacity of 1.91 gallons with a standard deviation of 0.74 gallons. Okay, so that's the big standard deviation question. Is this standard deviation a population standard deviation, or does the standard deviation come from the sample, in which case we would call it an S? And if we look at the sentence where we see the word standard deviation, we should be able to figure that out. A random sample of 30 dirt bikes has a mean fuel capacity of 1.91 gallons and a standard deviation of 0.74. So that standard deviation comes from a sample, and so we're going to call it S. And the problem asks, so this is the next question, the next sentence has the question mark in it, so let's look at that. At the 10% significance level, so alpha is 0.10, do the data provide sufficient evidence to conclude that the mean fuel capacity of all dirt bikes is less than 2 gallons? Okay, so my alternative hypothesis is less than. The key word was less than, and the null mean was 2. All right, so we're kind of set up for the problem. We're going to do a critical value approach. We see that alpha is 0.01, 10%. And now we have to decide if we're doing a t-test or a z-test. So step 3 is always a statement, a calculation of the test statistic. So we just have to figure out which test statistic. And when we go to the formulas, chapter 9 says, for sigma unknown, we're going to use T. And the formula for T is X bar minus mu naught. It's the same numerator, but the denominator is S over the square root of N. And furthermore, we should note that the degrees of freedom are N minus 1. I'll put that down here. And in this case, that's going to be 29. So we'll use that in the next step, but we just want to be able to have that available. Okay, so my T statistic is going to be 1.91, X bar minus mu naught, which is 2. And the denominator is 0.74 divided by the square root of 30. Okay, we're going to do the same thing, numerator divided by denominator. So go ahead, take the calculators out, and let's get that figured out. Negative 0.09 in the numerator, and in my denominator, um, 0.135. Okay, so now working the division. I'm getting negative 0.66. Okay, so that's, we can take it to 3 decimal places. The T tables are to 3 decimal places, so we can use, we can calculate our test statistic to 3 decimal places. All right. So step 4 is going to be a determination of the rejection, non-rejection regions, and we need to have a graph. This is a T with 29 degrees of freedom, and that will help us when we have to go and look up the critical value on the table. Step 1 tells us the shape of the rejection region, so this is going to be a left tail. And step 2 tells us the size of the rejection region. Okay, and that's going to be 0.1, 0.10, 10%. Okay, and remember what we have here is the T with degrees of freedom equal to 29. So let's go ahead and come this time to the T table. So it's the back page. And we want to go to the row 29. And the column 0.1. So I am getting 1.311, but this is the left tail, so we need to make sure we have the negative sign on that. Okay, critical value approach. This is my do not reject, the null hypothesis region, and over here is my rejection region. So that's step 4. Step 5 is going to be that we take my test statistic from step 3 and plot it on the graph that we built in step 4. So negative 0.666, it's to the negative side of 0, to the left of 0, but not all the way over past that critical value. So it's going to be somewhere like that. And I'll just write it in. T is equal to negative 0.666. And so my decision is determined by the region in which the test statistic falls. In this case, T equals negative 0.66 is in the do not reject H naught region. So my decision is to do not reject the null hypothesis. Okay, and the final step is the conclusion. And that is at the 10% significance level, the data does not provide sufficient evidence to conclude that the mean fuel capacity is less than 2 gallons. All right. So after you review those problems, if you'd like to chat, send me an email and we can set up an appointment.